For more than 40 years, OKW has been a market leader in the design and manufacture of high-quality standard plastic enclosures for EO/EM electronics equipment. To find a perfect housing for your latest design, check out our website at okwenclosures.com.
Welcome to WDD's HotSpot, sponsored by OKW Enclosures. I'm Jennifer De La Osa, Associate Editor, and in this week's episode we have self-driving trucks powered by 5G, object detection in high resolution, and researchers power up a brain-like supercomputer. Powering an all-electric driverless truck, 5G is being put into motion at a facility in Sweden, thanks to the collaboration of Einride, Ericsson, and Telia. The Einride's T-Pod, which was the driverless vehicle that operated continuously at the facility, received high-performance connectivity via the Ericsson radio system and Ericsson Cloud Core for 5G. According to the team, 5G represents a transportation paradigm shift. The connectivity brings with it ultra-low latency and high data speeds that can spring fleet management towards its next stage. Einride's autonomous electric transportation system, armed with the power of 5G, has potential to replace more than 60% of today's transportation, thanks to its sustainability and cost competitiveness. The technology can also help reduce CO2 emissions by more than 90% and eliminate nitrogen oxide emissions. Carnegie Mellon University researchers developed a model that can detect objects in high-res 4K and 8K video footage using GPUs. The team's attention pipeline method uses two-stage evaluation of each image or video frame. It does this under rough and refined resolution. Overall, the process reduces the number of required evaluations. After the new model was turned into code, it was distributed across GPUs. They were able to maintain high accuracy with a performance of 3 to 6 frames per second on 4K videos. For 8K videos, they reached an average performance of 2 frames per second. According to the team, the time needed to process high-res images reduced by 20% using their new method. This reduction is compared to processing every part of the original image under high resolution. After 20 years in conception and 12 years in construction, a supercomputer designed to function like the human brain was switched on for the very first time Friday, November 2nd. Developed by University of Manchester researchers, the spiking neural network architecture, known as Spinnaker, is armed with a processor core that's 1 million strong, with each chip having 100 million transistors. The supercomputer can model more biological neurons in real time than any other machine on Earth. It's also unique in its design, since it mimics the brain's parallel communication architecture by sending billions of small amounts of information simultaneously to thousands of different destinations. Researchers hope to use Spinnaker to up our knowledge of the brain's inner workings. The team has already been able to simulate certain brain segments, running an 80,000 neuron model of a portion of the cortex. That's all for this week's episode. Make sure to check in on Facebook and Twitter and catch past episodes at wirelessdesignmag.com. For the WDD channel, I'm Jennifer De La Osa. Thanks for watching.